guys, this is Ms. Rogers. So we're going to go through our subatomic particle notes. You should be working on this on Wednesday, on October 7th, okay? So we're going to take notes in our chemistry notebook, and then you're going to upload a picture of your notes at the end of this activity, okay? So you're going to set up your notes, and at the top, you're going to title it Subatomic Particle Notes. And then our target is I can describe how subatomic particles determine the mass, charge, and identity of an atom. Okay, so you're going to write that at the top. As you're listening to this video, you can pause anytime you need a little bit more time to write things down. Okay, so you should have your target written at the top of your note page. So the first thing we're going to do is we want to think about how small really is an atom. When we're talking about subatomic particles, sub means like within. These are particles within an atom. So just how small is an atom anyways? We're going to watch this video, and then I'd like you to add some of the analogies that you hear to your notes.
You probably already know that everything is made up of little tiny things called atoms. You might even know that each atom is made up of even smaller particles called protons, neutrons, and electrons. And you've probably heard that atoms are small. But I'll bet you haven't ever thought about how small atoms really are. Well, the answer is that they are really, really, really small. So you ask, just how small are atoms? Well, to understand this, let's ask this question. How many atoms are in a grapefruit? Well, let's assume that the grapefruit is made up of only nitrogen atoms, which isn't at all true, but there are nitrogen atoms in a grapefruit. Well, to help you visualize this, let's blow up each of the atoms to the size of a blueberry. And then how big would the grapefruit have to be? It would have to be the same size of, well, actually, the Earth. That's crazy. You mean to say that if I filled the Earth with blueberries, I would have the same number of nitrogen atoms as a grapefruit? That's right. So how big's the atom? That's really, 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 really small. And you know what? It gets even more crazy. Let's now look inside of each atom. And that's the blueberry, right? What do you see there? In the center of the atom is something called the nucleus, which contains protons and neutrons. And on the outside, you'd see electrons. So how big is the nucleus? Well, if atoms are like blueberries in the Earth, how big would the nucleus be? You might remember the old pictures of the atom from your science class where you saw this tiny dot on the page with an arrow pointing to the nucleus. Well, those pictures, well, they're not drawn to scale, so they're kind of wrong. So how big is the nucleus? So if you popped open the blueberry and were searching for the nucleus, you know what? It would be invisible. It's too small to see. Okay, let's blow up the atom, the blueberry, to the size of a house. So imagine a ball that is as tall as a two-story house. Let's look for the nucleus in the center of the atom. And you know what? It would just barely be visible. So to get our minds wrapped around how big the nucleus is, we need to blow up the blueberry up to the size of a football stadium. So imagine a ball the size of a football stadium, and right smack dab in the center of the atom, you would find the nucleus. And you could see it. And it would be the size of a small marble. And there's more. If I haven't blown your mind by now, let's consider the atom some more. It contains protons, neutrons, and electrons. The protons and neutrons live inside of the nucleus and contain almost all of the mass of the atom. Way on the edge are the electrons. So if an atom is like a ball the size of a football stadium with the nucleus in the center and the electrons on the edge, what is in between the nucleus and the electrons? Surprisingly, the answer is empty space. That's right, empty. Between the nucleus and the electrons, there are vast regions of empty space. Now, technically, there are some electromagnetic fields, but in terms of stuff, matter, it is empty. Remember, this vast region of empty space is inside the blueberry, which is inside the Earth, which really are the atoms in the grapefruit. Okay, one more thing, if I can even get more bizarre. Since virtually all of the mass of an atom is in the nucleus, now, there is some amount of mass in the electrons, but most of it is in the nucleus. How dense is the nucleus? Well, the answer is crazy. The density of a typical nucleus is 4 times 10 to the 17th kilogram per meter cubed. But that's hard to visualize. Okay, I'll put it in English units. 2.5 times 10 to the 16th pounds per cubic feet. Okay, that's still kind of hard to figure. Okay, here's what I want you to do. Make a box that is 1 foot by 1 foot by 1 foot. And let's go and grab all of the nuclei from a typical car. Now, cars on average weigh 2 tons. How many cars' nuclei would you have to put into the box to have your 1 foot box have the same density of a nucleus? Is it 1 car? 2? How about 100? Nope, nope, and nope. The answer is much bigger. It is 6.2 billion. That is almost equal to the number of people in the Earth. So if everyone on the Earth owned their own car, and they don't, and we put all of those cars into your box, that would be about the density of a nucleus. So I'm saying that if you took every car in the world and put it in your 1 foot box, it would have the density of 1 nucleus. Okay, let's review. The atom is really, really, really small. Think atoms in a grapefruit, like blueberries in the earth. The nucleus is crazy small. Now look inside the blueberry and blow it up to the size of a football stadium, and now the nucleus is a marble in the middle. The atom is made up of vast regions of empty space. That's weird. The nucleus has a crazy high density. Think of putting all those cars in your 1 foot box. I think I'm tired.
So take a moment and add a few of the analogies that you just listened to your notes, just kind of thinking about how small an atom is. Okay, it's almost incomprehensible. And what we're going to look at is the even smaller particles, are subatomic particles. Okay, so let's get some definitions down. Okay. So an atom is the smallest unit of an element that retains the chemical properties of that element. So that means an atom of oxygen has all the same chemical properties as a whole bunch of oxygen atoms. Okay? And so that's what an atom is. So what is a molecule? We tend to use those words interchangeably. A molecule is a group of atoms bonded together. So when you see those little subscripts, like the 2 on the H2 at the bottom of the screen, it's considered a molecule because it's made up of more than one hydrogen atom. Okay, so we see H2 means there's 2 hydrogen atoms. An atom would just be H. Okay. The other 2 words that you'll use that sound really similar are isotope and ion. And we'll look a lot more at isotopes, but isotopes are atoms of the same element. So they have the same number of protons, but they have different masses, so different numbers of neutrons. And ions are atoms with the same number of protons, but have an overall net charge. So they have a different number of electrons. If you're like, okay, I kind of get that. You saw a little bit about this in the PhET. You saw some isotopes, and you saw some ions, some atoms that had charges. And we're going to spend a lot more time with both of these. Okay, so for right now, we're just getting down some definitions. Make sure you have down in your notes atoms, isotopes, ions, and molecules. Let's look a little bit more closely at those particles themselves. We have electrons, protons, and neutrons. And so this table kind of gives you a lot of information about each of them. So the first particle we'll look at is an electron. An electron, the little symbol here is going to be an E with a negative sign, okay? And so they live in the electron cloud, and that is that cloud of empty space around an atom, okay? Electrons are just kind of hanging out there. They have a negative charge, and they weigh very, 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 very little, okay? So we have 2 columns here for mass. We have relative mass and actual mass. So let's look at the farthest column that says actual mass. The actual mass of an electron is 9.11 times 10 to the negative 28 grams. That is really small. Really, 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 really small. Okay? However, if you look at that mass and you compare it to the next to the mass of the proton and the neutron, which is 1.67 times 10 to the negative 24th, that electron is about 10,000 times smaller than a proton or a neutron, which means we don't really count the mass of electrons when we think about the mass of an atom. Okay? It kind of be like taking an elephant and wanting to get the mass of the elephant. And so you put an elephant on the scale, and then I add a couple grains of rice on top of the elephant. Okay? Realistically, that rice has some mass. Like there's, maybe 0.2 grams that come from the rice that I've added. But realistically, the elephant still weighs basically the same thing because that rice weighs so little that it's practically negligible. And so this word negligible means that normally something is so small that we just don't count it. So we don't count really the mass of an electron in our overall mass of the atom. So that second to the right-hand column, relative mass, AMU is atomic mass units. And so we say electrons have approximately 0 atomic mass units. They don't really have anything. They don't really have mass that matters to us. Okay. Our other two particles are protons and neutrons. And so protons, their symbol is a P with a plus sign, and they are housed in the nucleus, in that super dense center. And they have a positive charge, which is what gives the nucleus a positive charge overall. Okay. Each proton is 1 AMU, so 1 atomic mass unit for each proton you have. Okay. The same size particle is a neutron. So neutrons also have 1 atomic mass unit. So when we're looking at the mass of an atom, we normally add up the mass of how many protons and how many neutrons we have. Neutrons normally have the symbol of an N with a 0 at the top. And that 0 is because they have no charge. They are neutral. They also are in the nucleus, and they help protons stick together. So we didn't actually learn about how we figured out about neutrons. Just so that you know, neutrons were discovered by a scientist named James Chadwick around 1930. And he found a particle that had no charge, but it was about the same size as a proton. And so it helped explain what isotopes were and how all those positively charged protons were able to stick together in the nucleus and not fly apart. Right? If you think about two positive sides of a magnet trying to push them together, they repel. And so neutrons allow those positively charged protons to stick close to each other and not repel each other. Okay? We'll see neutrons a lot when we talk about radioactivity later on in the unit. Okay. So we've got our 3 particles, electrons, protons, and neutrons. Here are some things that you should have seen in the PhET. Okay? About each atom, we can determine what element it is, what its mass number is, and what is its charge. So the element ID, what element something is dependent on the number of protons. And that is the same thing as the atomic number. Okay, so if I have 13 protons, I'm aluminum. If I have 7 protons, I will be nitrogen. Okay, if I have 92 protons, I'll be uranium. Okay. My mass number are the number of protons plus the number of neutrons. As we said in the last slide, electrons don't have very much mass, and so we just kind of assume that they have a mass of 0 AMU. So we only take into account particles that have mass, protons and neutrons. So our mass number is going to be the number of protons plus the number of neutrons. So if I have an atom that has 6 protons and 7 neutrons, if I have 6 protons, I'm going to be carbon. And then my 6 protons plus my 7 neutrons is going to mean a mass number of 13. Okay. The other thing that I need to take into account is charge. Okay, so only particles that have a charge, which are protons with a +1 charge and electrons with a -1 charge, are going to impact the charge of an atom. So to calculate the charge, I'm going to take the number of protons and I'm going to subtract the number of electrons. So if I have a fluorine atom that has 9 protons and 11 electrons, I'm going to take 9 minus 10, I believe I said 11 electrons. It's going to have 10 electrons. So my fluorine atom has 9 protons. I'm going to subtract the 10 electrons, and so that gives me a charge of overall -1. So what I can do, if I have all those pieces of information, is I can write what is sometimes called an atomic or a nuclide symbol for any atom. Okay, and so you see here for magnesium, we have the symbol in the middle. So that is what identifies the element. In the bottom left-hand corner, we have the atomic number, or the number of protons. In the top left-hand corner, we're going to have the mass number. So that's the number of protons plus neutrons. And in the top right-hand corner, we're going to have the charge. Okay, and so that's going to be the number of protons minus the number of electrons. For any atom, I can also write a name, not a symbol. And so to do that, I'm going to write the name of the element and the dash the mass number. Okay. If it has a charge, I'm also going to add the word ion to the end of it. So if I were to name this symbol right here for magnesium, it would be magnesium-24, and then I'd write ion because it has a charge of +2. Okay, so example here, we have sodium. It has an atomic number of 11 and a mass number of 23, which means that it has 12 neutrons. Okay, it has a charge of +1. If its charge is +1 and it has 11 protons, that means it must have 10 electrons. If I want to write this as a name, I'm going to write sodium, because it says Na-23, my mass number, and then ion at the end. Okay. So here is a table for you to practice trying to determine the name, symbol, atomic number, mass number, number of neutrons, and number of electrons, and the charge for each atom. Okay, so at the top, I have done one example for you. Okay, so we have the potassium-40 ion. If I write the symbol for that, it's going to be K40/19 with that positive sign in the upper right-hand corner. Potassium's atomic number is 19. And from the symbol and the name, I can tell the mass number is 40. The number of neutrons is equal to the mass number minus the atomic number, so it's going to be 21. My number of electrons needs to relate to the number of protons I have. If you remember, atomic number is the same thing as number of protons. So I know I have 19 protons, and I have an overall charge of +1. So that must mean I have 18 electrons. Okay. So if you look at this table, what I'd like you to do is copy it down into your notes, and then take a moment and try and fill in the missing pieces of information. Okay, so determine what the symbol would be, the atomic number, the mass number, the number of neutrons, electrons, and what the charge would be. My advice would be to leave the symbol for last. Okay, so take a moment, pause the video. There is information at the bottom to remind you of how to calculate each of these pieces. Okay. Okay, so let's try doing a couple of these together. So let's look at neon 20. So neon 20, what I know is that my element is neon. And so if I look at my periodic table, I can tell that the atomic number for neon is going to be 10. Okay? And from the name, I know that 20 is going to be my mass number. So 20 is going to be my mass number. Now, my number of neutrons, if I look down here, mass number is protons plus neutrons. So if I want to find how many neutrons, I need to take the mass number and subtract the number of protons. So 20 minus 10 is going to be equal to 10 neutrons. I see that I have a charge of 0, which means I must have the same number of protons and electrons. So if I have 10 protons, because my atomic number is also my number of protons, then I must have 10 electrons. And so my last step is I'm going to write this symbol. Neon is Ne on the periodic table. So I'm going to write Ne. And then my mass number goes on the top, and my atomic number goes on the bottom. And because my charge is 0, I don't need to write anything on top. Let's look at the next one. What I see is that I have a mass number of 107, I have a number of neutrons, and I have a number of electrons. Okay? And so I am going to calculate my missing pieces of information. So if I know what the mass is and I know what the number of neutrons is, I can determine how many protons I must have. And that's going to be equal to my atomic number. And so I'm going to say that this is 107 minus 60. Because there's my mass number minus the number of neutrons. If I put that in my calculator, what I'm going to get is 47. If I look on my periodic table, I will see that 47 is silver. Okay? And so now, equal sign. So now I can look and I see that I have 47 protons and I have 47 electrons. So that actually means my charge is 0 because I have the same number of protons and electrons. 47 minus 47 would be 0. So last thing I need to do is kind of finish my name and fit right on the symbol. So for the name, I need to put my mass number at the end. And for my symbol, I need to start with the symbol for my element, which for silver is going to be Ag. And then I need to put my mass number at the top, 107, and my atomic number at the bottom, 47. So let's do the last one together. I've got an atomic number of 33, a number of neutrons, and a number of electrons. Okay. So the first thing I can do is I can calculate my mass number by taking the number of protons and adding my number of neutrons. So 33 plus 42 is going to be 75. So the other thing that I need to do is I need to determine what the charge is and then what the identity of atomic number 33 is. Okay? And so let's start first with the charge. And so we're going to say, because atomic number is the same as number of protons, and I don't have the same number of protons and electrons, I need to calculate the charge. So I'm going to do 33, my number of protons, minus 36, my number of electrons. And so that's going to get me negative 3. Okay. So my last step is to figure out what element this is and fill in all this information. So element 33 on the periodic table is going to be arsenic. Okay. And I need to put my mass number at the end, so arsenic 75. And because it has a charge, I'm going to write ion after it. Doesn't really want to make a dot. There we go. Okay. So arsenic, if I look up, the symbol is AS. So I'm going to put my mass number up at the top, my atomic number at the bottom, and my charge up at the top. And there we go. We've finished our practice. So if we check our key, we can see that yes, we got each of those pieces correct. Okay? So last thing you're going to do is at the bottom of your notes, you're going to make these 3 boxes for key terms, connections, and questions. The key terms box, you're going to list all the key terms from these notes. From the connections box, you're going to write how do you see this information connecting to what we've already learned so far in class? So think maybe back to atomic history. What did we learn about the history of the atom, and how might that connect to what you took notes on today? And then the last box are what questions do you still have? What do you want to know more about? What are you curious about? You're going to take a picture and upload your notes on the assignment on Canvas. Okay? And if you're curious, just a little bit of supplemental information. If you want to know if there's something smaller than a proton or a neutron, here's some interesting information about quarks. You may have heard of them. They're an elementary particle of matter. They're actually what makes up protons and neutrons, and they're super confusing and weird. It's not at all anything you have to know, but if you want to learn a little about them, there's information on this slide, and there is a video that you can watch. Again, I'll never hold you accountable to this information. Just some kind of fun things for you to learn. But what you need to make sure you do is fill out this box, take a picture, and upload your notes. And I'll be excited to see you guys soon.